All right, 6.4, confidence intervals for variance and standard deviation. So the chi-square distribution, the point estimate for population variance is sample variance. The editing threw this off a little bit, so please excuse the spaces. And the point estimate for a population standard deviation is sample standard deviation. The most unbiased estimate for population variance is sample variance. So you can use a chi-square distribution to construct a confidence interval for the variance and standard deviation. If a random variable x has a normal distribution, then the distribution of chi-square equals n minus 1, remember, the degree of freedom, and then this is a variance divided by sample variance divided by population variance, forms a chi distribution for samples of any size n greater than 1. All right, so just as a reminder, this is population standard deviation. This is variance, so population variance. All right, all values of chi-square, this is the chi-square distribution. All values of chi-square are greater than equal to 0. The chi-square distribution is a family of curves, each determined by the degrees of freedom to form a confidence interval for population variance. Use the chi-square distribution with degrees of freedom equal to 1 less than the sample size. So what this is usual. The total area under each chi-square distribution curve is equal to 1. The chi-square distribution is positively skewed, and therefore the distribution is not symmetric. So we'll come into play in a few minutes. The chi-square is different for each number of degrees of freedom, as shown in the figure. As the degrees of freedom increase, the chi-square distribution approaches a normal distribution. So let's look at our figure. So notice this is not symmetric. So we're not going to have a center. So we're not going to be able to add and subtract easily like we did for the other confidence intervals. So there's no plus or minus because this isn't symmetric. All right. So the degree of freedom 2, you can see it's this is the curve right here. Then degree of freedom 5. Then 10. Then 15, then 20. See how it kind of levels out after the n increases. All right. So there are 2 critical values for each level of confidence. The value chi-squared r represents the right tail critical value, and chi-squared l represents the left tail critical value. Table 6 in Appendix B lists the critical values of chi-squared for various degrees of freedoms and areas. Let me pull this out right quick. So here's our table, Table 6. You have your visual right here, as you can see. Degrees of freedom are on the side. So notice degree of freedom, not n. And then our level of significance here. All right. Notice this is limited. So you want to, as we did the last time, you want to choose the DF that's closest to it without going over. So go under your DF if you have to. All right, so like for 4950 would be closer to 49, but we don't want to go over. So we would choose this DF if we had a DF of 49. All right. Switch on. So identify the confidence level, find the DF, and the area to the right is 1 minus C divided by 2. Area to the left is 1 plus C divided by 2. Find the area listed on the top row of the 6 that represents the region under the chi-square curve to the right of the value. So let's practice that real quick. So we have the chi-squared R and chi-squared L for a 95% confidence level interval when the sample is 18. I did not give myself enough room to work this out, so I'm just split this up. All right, so to make the chi, I try to make one of these, this one straight, this line straight, and then the other one squiggly. It's the best I can do. All right, so for the right, we have 1 minus c divided by 2. So this is going to be 1 minus 0.95 divided by 2. I don't have the picture here, but we're going to do it together. 1 minus 0.95. Notice how I'm doing this. Then divide by 2. You want to make sure it's separate, or you want to put it all in one. So it's 0.025 for the right. For the left, excuse me. It's 1 plus c divided by 2. So 1 plus 0.95 divided by 2. I just went up, copied, plus, divide by 2. So that's my alpha level significance, which we use our confidence levels to get that. So first, we have our 0.025, trying to get the same area. And then our n is equal to 18, which means df is equal to 17. Okay. So 17, we do have a number for that. 0.025. 30.191. So 30.191. For the right, 0.975, 17, 7.564. So that's how you find your critical values. So use your table like you did for, it's more similar to T distribution. All right, let's look at these confidence intervals. So again, we know that chi-square distribution is not symmetric, so we must perform separate calculations. So we can't do the plus or minus thing. So to find a confidence interval for population variance, this is our formula. And to get the standard deviation, we're going to square root. All right, so again, there is no calculator function to calculate the confidence intervals for population variance and population standard deviation. So we'll need to substitute the numbers into the formula, then simplify in the calculator. So again, we don't have any equality. It's not the same on both sides, so we can't plus or minus. All right. So you randomly select and weigh 30 samples of an allergy medicine. The sample standard deviation is 1.20 milligrams, assuming the weights are normally distributed. Construct 99% confidence intervals for the population variance and standard deviation. So population variance and standard deviation. Trying to get my variance together. All right, so first we need to find our critical value. And we have two. Squiggly line. Right. 1 minus c divided by 2. And then squiggly line, left, 1 plus c divided by 2. This is not on your formula sheet, so you're going to have to remember this. So this is 1 minus 0.99 divided by 2. 1 plus 0.99 divided by 2. Zero point 0.005. 0.995. Yes, there will be opposite. So if you notice that, it will be. Now let's get our critical value. N is equal to 30. DF is going to be equal to 29. So let's get our actual critical value. Pull up my paper. Sorry, I put it up. I don't know why. So 0.005. DF of 29. 0.005 is that first one. So it's 52.336. My last one, 52.336. And then the left is going to be 0.995. 13.121. All right, so let's get our formula. I'll use my formula sheet because I flipped over already. So n minus 1 s squared over chi squared r. N minus 1 s squared over chi squared l. So n minus 1 over s squared. Actually, I'm just going to plug those numbers in. I think we're good with the formula. Trying to find my whiteout. Can't find it. Let's plug these numbers straight into the formula. So this is going to be 29 times standard deviation squared over our right and then 29 times standard deviation squared over left. Okay, and that gives us make sure you can see this. Two decimal places, so 0.80. Notice how I'm just going up and copying pretty much to save me some time. So this is variance. Not putting parentheses because, again, we don't have a middle. So now to get the actual standard deviation, the population standard deviation, you could do a few things. You can take your actual answer. Please don't take this answer, take the square root. Take your actual answer square root and get your number. Okay, so square root, you can go up and actually copy. So hit the square root button, copied that last answer. Square root, copied the answer. So again, you don't want to take this number in square root. You want to take the actual answer in your calculator. So answer, to get the answer, is second answer, or you just go up and highlight. Depending on how old your calculator is, you can go up and highlight. So for the population standard deviation, we have 0.89 and 1.78. So that's a calculator shortcut. Make sure you go up, copy, and paste. All right. So for your homework, you may have an interpretation. So I do want to give you an interpretation so you can have it. So this is the standard interpretation, and you want to plug in according to your problem. So this is standard, and I'm going to plug in my answers. With 99% confidence, you can say the population variance is between 0.80 and 3.18, and the population standard deviation is between, you're going to put your numbers in, 0.89 and 1.78, and then whatever your unit is. So for this, it's going to be milligrams. All right, so chi-squared, again, we couldn't put the parentheses around our intervals because there is no center. Chi distribution, according to that our graph, there is no symmetry, so we're just going to leave our answers as is. And then when you are interpreting, you're going to use that blanket interpretation, and you're going to stick your numbers in with your unit at the end. All right, till next time.